In the name of Allah, the compassionate and the merciful. Hello guys. In this video, we're going to talk about the forecasting net income margin with using Monte-Carlo method in uncertainty conditions. Suppose that you have a company and you wanna forecast different seasons or next year's net income or net income margins value, but you don't know the exact values. So what did you do? In this video, we're going to define and introducing the Monte-Carlo method with using beta PDF for forecasting the net income margin with using this process. So let's see the Python code. You see that in here we have income statement with revenue, direct material cost, direct labor cost, overhead cost, cost of goods, with defining the pessimistic and optimistic value with different alpha and beta coefficient. For example, for revenue, we defined alpha equals to 1 and beta equals to 2 as this shape. Let's see this shape. You see we have 200, 400, and 200 has more frequency and 400 has less frequency. And direct material cost, you will see that we have pessimistic 100 and optimistic 200 with the most frequency is in here. So let's back to the code. You will see that with the summation of these three values, we have cost of goods and gross profit, revenue minus cost of goods, and operating expense is defined with some values with the pessimistic and optimistic, and also comes to the net income and net income margin. If we're going to plot it, you will see that cost of goods it has this shape, and also net income margin has this shape with this value as a median of this value, which we indicate this median for our optimum scenarios for predicting of net income margin. You will see that the shape is really near to be normal PDF, and so we use this method with using probability distribution function and Monte-Carlo method with uncertainty conditions with 100,000 iterations to calculating the net income margin as a median ones going to be selected. So let's back to the Excel file, other simulation. You will see that I defined the pessimistic and optimistic values for revenue, direct cost, and other values. You will see in here, and using the random numbers with beta distribution, and also calculating the gross profit, operating income margin, and net income margin, and also for 100,000 iterations for all the values as a gross profit margin, operating margin, and income margin, and also the revenue, cost of goods, operating expense, and net income margin. And after running these 100,000 iterations, you will see that in here we're going to calculate these values for each of these columns. You see that in here. So what is the, for example, what is of our result for example, revenue, for predicted revenue. So in my opinion, we must use the median values. For example, for revenue, we have these values. For cost of goods, we have these values, and also net income margin, we use these values, and also gross profit margin, operating margin, and also net income margin. We use the median statistics value, and let's show the net income margin probability distribution. You see that it is really, the shape is going to be normal. So you will see that in this process we use probability distributions functions in uncertainty conditions for forecasting the next values of our model. For example, in here we use financial statement. So, and you can have different method for this prediction, but in here we use different scenarios for pessimistic and optimistic values. In here you can change minimum and maximum or different coefficients for alpha and beta, and also in Python code for different scenarios, different values. So if you